Hello and welcome to another video. In this video we're going to be working on number of laser beams in a bank. And in the problem you're given a zero-indexed binary string array bank representing the floor plan of the bank, which is a m by n 2D matrix. And bank I represents the ith row consisting of zeros and ones. 0 means it's empty and 1 means there is a laser or security device. And there is a laser beam between any two security devices if both conditions are met. The two devices are located in different rows, and this is kind of the tricky part to understand, but essentially, in order for there to be a laser beam between two devices, there have to be no devices on any row between them. So for example, if there was a device here, then these would not exist, right? So the reason there are beams between these two rows is because there's nothing in between them. For these two rows, nothing between them as well. And that's kind of like the crux of the problem, and that's what makes it pretty easy. Laser beams are independent. One beam does not interfere with others, so like all these don't interfere with each other, and return the total number of beams. So in this first example, we have 3 security devices on the top row, and then we have 2 here. And basically what's going to happen here is for every 2 rows that there's nothing in between, you're going to have a laser from every device on the top row to every device on this row. So we can label these like 1, 2, 3, and then we can label these 1 and 2. And so you'll have something like it'll go from 1 to 1, from 1 to 2, from 2 to 1, from 2 to 2, from 3 to 1, and from 3 to 2. So essentially what's going to happen here is every single device on this row will emit to this row, and the number of devices, the number of total lasers, will just be the number of devices multiplied by each other, right? So the number here times the number here, because every single device will emit a laser. Similarly down here, these two, there's nothing between them, so each one of these will emit a laser to this. So it's kind of straightforward how to do this, right? You basically just look at adjacent rows, and every time there's an adjacent row, the number of laser beams will just be the top row times this row. So here there's 3 times 2 plus this part here, which is 2 times 1. And in the second example, there is 1 row of devices, but there is no other matching row of devices. But yeah, so pretty much all we have to do is like our algorithm is just go through each row, right? Go through each row, and we can actually show what this is going to look like. So let's actually make a matrix of a few numbers. So let's just say we have something like this, and then we can demonstrate it. And we'll just have the ones and zeros. So let's just say like 1, 0, 1, 0, 1, all zeros. 1, 1, 0, 0, 1, 1, 1, 1, 1, 1, and let's say all zeros. So basically, all we're going to do is count up a total for each of these rows, just get the string. So we can do that on the side. So there's 3 here, 0, 3, 5, and 0. And we can do this like as we go. We don't need to pre-compute this, so we don't need to have any extra storage. But essentially, we just have some kind of current number that we have. And the easiest way to do this is just initialize to 0. So we'll have some current number. I'll just mark it with a C, make it 0. We'll have a result variable. And then for every row, we're going to calculate a total. If its total is 0, that means we don't need to do anything. We can just go to the next row. But like, for example, here, our total would be 3. And then we just say, if our total is non-zero here, right? So actually, this current is still going to stay 0. So we're going to have a total variable also. So this total will be 3. And if our total is non-zero, basically multiply this total times our old total that we have stored, because essentially any 2 rows that are right next to each other with nothing in between, the number of laser beams is going to be the number in that row and the row, the last row stored. So here we'll have 0 times 3, which will be 0. And then we will store this new total in current. Then we're going to sum up this row. It's going to be 0. The total is going to be 0 here, so we don't really need to do anything. Then we go to this row here. Our total will be 3. So we basically need to multiply this total by the old total that we had, which is, instead of current, you can call it like old total or whatever. But we'll multiply these, so we're going to get 9 here. And then we will replace our old total with this new total. So this old total gets replaced by 3. Total 0. Then we go to the next row, and we have a total of 5. Yeah. So basically that's going to be our new total. Then the same thing, we just multiply the current times the total. So we'll add 15 here, and then we will replace the old total with the new total. So 5. Then for our last row, it's 0, so we don't need to do anything. But essentially, if you think about this, where are the lasers going to occur? They're going to occur between these two rows. There will be 9 of them, right? All of these beams will shoot on all of these beams. 9 different ways to do that. And then also there will be one here, right? So all of these beams will shoot on all of these, which will be 15. And that's kind of all you have to do. Anytime you get a row of zeros, you just ignore it. Anytime you get a new row, you just figure out what was my old one, because there's going to be an interaction there. And then the total, the number of interactions is going to be the count of each one. And as soon as you get a new row, the one before it doesn't matter, because this beam will never interact, like this row will never interact with anything below this row, because in order for there to be a laser, there has to be nothing in between the two rows, right? So you only need to store a count of 2 rows, and then just multiply them every time you get non-zero numbers. So you'll get this times this. This will go away. You don't no longer need it. We'll store this now. Then we'll get this times this. This will go away. No longer need it. We'll store this now. And then there's nothing here. And that's basically it. So we can code it up. So we're just going to loop. We're going to have a result variable. We can have like an old total. Maybe that makes a little bit more sense. We'll make it 0, and then we'll make like a new total or something. Make that 0 as well. So basically we have to go through every single row in the bank. So we can just say for row in bank, which will just be a string. So here you can either go through all the letters, or you could use a count in Python to get the number of times something occurs. So we can just say new total equals row dot count, and then you just pass in a character or whatever substring, and then you'll get a count of how much it occurs. So if you just pass in 1, you'll just get a count of how much the 1 occurs. You could also loop through, like you could have a nested loop in here, right? You can just say like for char in row, if char is 1, add 1 or something. That's also fine. Basically does the same thing. So now that we have this new total count, essentially all we got to do is, if it's 0, we can just ignore it, right? So we can just say like, if new total is non-zero, then we'll do something. If it's 0, we don't care. We'll just go to the next row. So if new total, we need to add to the result the new total plus the old total, or times the old total. And we need to replace the old total with a new total. And that should basically be it. So now we can just return the result. And there you go. So pretty simple. Yeah. And then as far as runtime, it's kind of weird. Like it was all over the place. Like I got something in 300 ms as well. So I think because this is kind of like an easy one and there's not too much involved, it just depends on like how many variables you have and exactly the stuff. So I'd say for this one, the runtime doesn't really matter. And what was I gonna say? Oh yeah, so like as far as the actual problem, yeah, the hardest part is just reading the description, figuring out what they're actually saying. But the actual implementation is easy once you realize, like, once I have a row and I get another row, I no longer care about the previous row because there will never be an interaction. All I need to do is just store the current total for the row, and the number of interactions is just the number for the old row times the number for the new row. So the implementation is pretty easy. The longest part of it is just reading the description and figuring out what's going on. So yeah. So for the time, it's going to be O of... So this is going to be like m by n, because I think they kind of said it as well. So you have m by n matrix. So like if you have m rows and n columns, basically you are going through every single row, and then this count obviously will read through every single string. So you're still doing like an m by n, where m is the number of rows and n is the length of the string. And space is O of 1, because we just have some constant variables here. So yeah, kind of another easy medium, not too bad. And if you did like this problem, please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.